Hi, and welcome to your Molar Mass podcast. We're going to be looking at what is the mole and how do you calculate molar mass. All right, so we think of the mole as being the chemist's dozen. 1 mole is equivalent to 6.02 times 10 to the 23rd, either molecules, if you're talking about a compound, such as, I have no pen working, such as sodium chloride. Or we would say it's equivalent to 6.02 times 10 to the 23rd atoms if we're only talking about an individual element. So we use those two terms to describe it. That is a very arbitrary number. 6.02 times 10 to the 23rd you may recognize as being Avogadro's number. In previous classes you may have taken that out to 6.022. We're just going to leave it with 3 sig figs for this class. So that is Avogadro's number. This seems very arbitrary that you have this equivalence. I don't know what a mole is. I don't know what 6.02 times 10 to the 23rd looks like for something, but I want you to think of it as a numerical equivalent. So for example, when we say I have a pair of shoes, like we have right here, you're really telling somebody that you have 2. So 1 pair is equal to 2 shoes. If you tell somebody that you have a dozen donuts, everybody knows that that's 12 donuts that you have. So these are numerical equivalents. So when I say that I have 1 mole, it means I have 6.02 times 10 to the 23rd molecules of that substance. All right, so let's look at how to calculate molar mass, as well as look at the difference between formula mass and molar mass. So formula mass is where you're just adding your atomic masses from the periodic table, and your unit's going to be in AMUs. Something to keep in mind is anytime we deal with masses in Chem 1201, you need to make sure that you're always using 4 sig figs to report your mass. Thankfully, if you're using the periodic table that I gave to you, all of those numbers are already rounded to 4 sig figs. You just have to remember after you add them all together that you're also rounding to 4 sig figs as well. Molar mass is pretty much the same thing, but it's the mass in 1 mole of a substance. So the unit that we're using this time is grams per mole. Think of it more like a ratio for your molar mass, or for your formula mass, excuse me, which we'll be using in conversions later on. For compounds, you're going to add the atomic weights of the elements. So the only place this gets really tricky is when you start to get a lot of subscript going in one particular compound. That can be tricky, but we'll work through it. So let's start simple. 1 mole of NaCl. Well, what I need to do is I need to find the mass of a sodium and the mass of a single chlorine, add those together, and I have the molar mass. So looking at my periodic table, sodium is 22.99 rounded to 4 sig figs, plus chlorine, which is 35.45. When I add these together and round to 4 sig figs, I come up with 58.44. And because we're talking about molar mass, we're talking about the ratio of grams to moles in the substance, and you have 1 mole of it. My unit is going to be grams per mole. Okay? Another way that you can think about this is I have 58.44 grams of sodium chloride per 1 mole of sodium chloride. So that's actually a conversion factor for us. It's a ratio of grams to moles for that particular compound. So now let's do the same thing, but let's make it a little more difficult by having a molecule that has subscript. So what we're going to need to do is we need to calculate 1 carbon plus 2 oxygens, and we'll take the mass of those. Because our subscript tells us for this compound to exist, it needs to be in a 1:2 ratio. So carbon is 12.01, and then I can either multiply 2 times whatever the mass of oxygen is, or I can add the oxygen twice. I like to multiply. It seems like less steps. So 2 times the mass of oxygen, according to our periodic table, is 16.00. And 2 times 16 is 32 plus 12.01 gives us a total of 44.01 grams per mole. So this is saying I have 44.01 grams of CO2 per 1 mole of CO2.